Okay, so we looked at charts as a way to understand limits, about the closer to nature. Charts are great for understanding the closer, but they're not good for finding answers. Now we're going to look at graphs, and graphs are a great way to check things and great way to see pictures of what's going on, but they too will not be the way we fundamentally want to find limits. But being able to gather information from graphs is quite important, so we're going to do a lot of stuff with graphs. So previously we looked at this guy here, x squared minus 9 over x minus 3, and we saw that f of 3 was undefined and that the limit as x goes to 3 of f of x was 6. And we drew the graph before, and what we want to notice here is that as the x values get closer to 3, the graph comes close to the point 36, or the y values are coming close to 6. That as I approach both sides from the left and right, my y-coordinate is coming close to 6. Now we never quite get to 6, because at f of 3 it was undefined, so we never get to 6, but limits are about close to. And as we come closer and closer and closer to x equals 3, my y-coordinate comes closer and closer to 6. So your limit values are going to be your y-coordinates and what your y-coordinate is close to. Now I've kind of given some step-by-step directions on here. When given the graph of y equal f of x, define the limit as x goes to 4 from f of x. As x goes to 4 from the right, of f of x, and that's just example. You're going to point to a spot on the x-axis close to x equal 4 on the right. Then you're going to move your finger vertically, touch the graph of the function. Next, move your finger horizontally to the y-axis. The y value your finger is near is the limit. Similarly, to find x approaches 4 from the left of f of x, you're going to do the same thing, but start at a point to the left of x equal 4. For a two-sided limit, recall, there's the word I want, recall, a two-sided limit exists if and only if both the left and right limits exist and are equal to each other. In this case, all the limits have the same value. For a two-sided limit, find both the left and right limits, and if they're the same answer, that's the answer for the two-sided. If the left and right limits are different, the two-sided limit doesn't exist. So we're going to look at a graph, this one particular graph, we're going to look at it over and over again for various different values. Okay, so use the graph of the function to determine each of the functional values. So the first graph I have here is the limit as x approaches negative 3 from the left. And we will do this in green. Now, something you have to understand. My open and closed circles, open circle, closed circle, they are hugely magnified. They represent just a single point, in this case a single missing point. So they are hugely magnified. In reality, they should be microscopic. So they're hugely magnified, and they're intended to be above or below, directly above or below the number in question. So this open circle here is intended to be directly above negative 3. So as I do the limit as x approaches negative 3 from the left, I'm going to go and point to a spot close to negative 3 but on the left, and then I'm going to draw a vertical line and go and touch my function. So there I go and touch the function. I'm going to miss that open circle because that open circle is directly above negative 3, and I'm slightly to the left of negative 3. So I go vertically and touch the function. Then I move horizontally to the y-axis, and the value I'm close to is my answer. So in this case, we say that this looks like the limit as x approaches negative 3 from the left is 3. Now this is all ballpark. Graphs are always ballpark. So if someone told me the limit was 2.9, I'd be okay with that. But go with what you think I probably meant the answer to be. Next one, as x approaches 3 from the left. We will do that in pink. So same idea. I'm going to go and point to a spot close to negative 3 but on the right. Then I'm going to go up to my function and try to draw a straight line. So I go up to the function, touch the function, and then go over to the y-axis And the value you are close to is your limit. And so again, it looks like this is also going to be 3. Now the two-sided. Well, I have the left and right. So the two-sided also has to be 3 because the left equaled right equaled 3. A two-sided limit exists if and only if left and right limits exist and are equal. Then finally we have f of 3. f of negative 3. That's what's happening exactly at negative 3. That's the open circle. And so this is undefined because there is an open circle or no y-coordinate when x equals negative 3. And so here, undefined, because that corresponds to that open circle. Bring it down so you can see the open circle. That's supposed to be directly above negative 3, so there is no y-coordinate, and so no functional value. Okay, we're going to go on to the next one. Same graph, but this time we're going to look at 0. So the exact same graph, but 0. Now this one's a little harder to draw because I don't have much space here. But as x approaches 0 from the left, so in green again, we're going to do all the left ones in green. So I'd go right close to 0, but on the left, and I can't really draw any lines there. But my y-coordinate looks like it's 0. On the right, in pink, okay, go close to 0, but on the right. And again, I can't really draw lines, but it looks like my y-coordinate is 0, which makes my two-sided limit 0. Again, because left equaled right equaled 0. And then my functional value, we'll kind of do that in red. Well, I can't really do it in red. The functional value, what's happening exactly at 0, and that's going to be 0. Because there is the point 0, 0. My x-coordinate and my y-coordinate. So f of 0 equals 0. That here, because I have an actual honest-to-goodness point at 0, 0, I do have a functional value there. X-coordinates go in, y-coordinates come out. When I'm at x equals 0, I do have the y-coordinate of 0. And I think we'll conclude this video on these two guys.